Namaste everyone. In this video we'll be taking up this particular problem and we'll try to solve it. You can see this is an epicyclic gear train and the diagram has not been drawn right to scale, and hence the two gears C and D, even though they appear of different size, they are actually supposed to be of the same size. So whether you take C or D, you'll be just taking up the same gear twice. So we'll just be taking it only once. So as I had told in the previous video, we'll just have to build the table for such problems, and once the table is ready, the whole problem is almost solved. So let us proceed with the same process once again. So first, as I told, we have to take up the arm. Then we'll have to start with the sun gear, which in this case is the A gear. Then we'll have to take up the gear which is connecting with A. You can see C and D both are getting connected with A and they are both identical, and so we just have to take NC or ND. Both we can take up at the same place. And these two gears C and D, they are in turn connected with the epicyclic wheel, the annular wheel B. So that we have to take up at the end. So this is the order in which we'll have to take. The first step, the step 1, will be taking arm to be stationary. We'll give one rotation to the sun gear, which is A gear, and we will see, we'll find out how many rotations the other gears are turning. So when it comes to the C gear, we'll have to find NC by NA. This will be equal to minus TA by TC. Now we are getting it negative because they are meshing externally and their direction of motion will be opposite to each other. If this is anti-clockwise, this one will be clockwise. Hence we are taking it minus. So because NA, you can see here, we are just taking it by one rotation. So the equation for NC or ND, it reduces to minus TA by TC. The same way we'll have to build up the equation for NB, and NB is meshing with NC. So the relation between them we'll have to take up, it will be TC by TB, and there won't be a negative sign here because they are meshing internally. So if this one is rotating clockwise, the external annular wheel will also rotate clockwise. Hence we are not taking negative sign here. But this NC will have to transfer to the other side, and when we substitute the value of NC from here, we will get minus TA by TC multiplied with this whole term, that is TC by TB. Now here you can see TC will get cancelled and we will be left with minus TA by TB. So that's what we will write down over here, TA by TB. Let's go ahead with steps 2 and 3. That will be very easy once the first step is done. In the second step, we'll just have to multiply this with x. So 1 into x is x, this into x is x times TA upon TC, and this 1 into x is minus x into TA upon TB. So this is what we got in the step 2. So what we are doing in step 2 is, instead of just giving one rotation, we'll be giving x rotations. And in step 3, we will give y rotations to the arm. And because all the gears are mounted on the arm, all of them will get that many number of rotations. So the rotations gained by NA will be x plus y. Here it will be y minus x times TA upon TC. Right? I could have written it the y term afterwards. In that case, it would have looked like this. So minus TA upon TB, and we'll have to add y. So in order to avoid it looking like this, I have now written it like this. So this is the table which we need to form. And once the table is formed, everything is going to be very simple. We'll just have to substitute whatever values are given and then find whatever values are needed to be found. So if you read the question here, he is asking us the speed of the arm A. So in both the cases, we are supposed to find the value of y here. And we'll have to do that based on what is given to us. So here you can see the speed of A is given and the speed of B is given. So A speed, it is x plus y. So let us write down A speed is x plus y. So when we substitute the value of x, that is 100 clockwise we'll take it as positive, that's equal to x plus y. And the speed of b, that is nb. So nb, the formula is minus x dA upon dB plus y. So when we substitute the value, we will get is minus 50, because this is counterclockwise, we'll get minus 50 equals minus x times dA upon dB plus y. Now once again, if you read the question, the number of teeth on A and B both have been given. So using that, we'll be able to get an equation here. So minus 50 equals minus x times number of teeth on A, you can see it here, it is 80 here, and number of teeth on B, you can see here, that is 200. So upon 200 plus y. So now we have got the two equations, and there are two equations and two variables, so we can easily solve them to find the value of x and y. So what we'll do, we'll just substitute y equals 100 minus x into this equation, and we get minus 50 equals minus x times 8 by 20 plus, in place of y we have to substitute this value. Then we'll have to solve it. 100, if you send this side, 100 minus 50, we'll just get 50 over here, and x, if you get it common, we will be left with minus 8 by 20 minus 1. So we'll have to solve this out. So 4 2s are 4 5s are, so 2 by 5. So both we need to add. 2 plus 5 is 7, so minus 7 by 5 times x is what we get. So x value will be equal to 50 times negative 5 upon 7. Okay, so we'll have to simplify this. So you just need to use calculator, and 50 into 5 by 7, that gives us 35.71. So the answer here is minus 35.71 RPM. So the negative sign here says that it is rotating anti-clockwise. The negative sign says that it is rotating anti-clockwise. So x value is this one. Now substituting this value into the equation number 1, we get the value of y. So 100 equals x plus y is the equation number 1. Substituting, we get minus 35.71 plus y, and this if you send to the other side, we get 100 plus 35.71, that is the value of y. So y value becomes 135.71. So this is the answer for the first bit, 15th first bit. So for 15 first bit, this is our answer. Same way we'll have to find for the second bit. In the second bit, he is telling us that b is stationary. So instead of substituting nb, the same formula will come here as well. Minus x TATB, I will just substitute here itself. So that is 880 by 200 and plus y. So because NB, B is stationary, NB value will be 0, and NA, it's rotating the same way. So the second equation will be the same, that is 100 equals x plus y. So once again, we'll have to solve this equation. 4 2s are 4 5s are, and by solving this, we will be able to find it. So y equals 100 minus x, we'll have to substitute here. So we get 0 equals minus x times 2 by 5, and y we are substituting here. Okay, we got this, and then both the x terms are negative, so let us send them to the other side. 2 by 5 plus 1 equals 100, and x will be equal to 100 into 5 by 7. So once again, we'll have to use the calculator to solve it. So 100 into 5 by 7, that gives us 71.43. So 71.43. So this time we are not getting any negative value, which means this is actually rotating clockwise. So this is the solution for 5 second one. Fine. So these are the solutions. So hope you have understood this problem perfectly. So here we have another problem which is very similar to the previous one. In fact, we can use the same table that we created here for the first problem. The same table can be actually used here with slight variations, of course. The variations being instead of A, B, and C, the naming has been changed to numbers. So this is N1, this is N3, this is N4. So that's the only difference which you have to make. So here I have noted down the table as it is, and now let us see what are the given stuff. I think the number of teeth and all the gears has been given to us. There won't be any problem with that. And so if you read the question carefully, he's talking about link 2. This link 2 is serving as input to the train. And the link 2, you can see here, this number here is the link 2. So here the arm is what is the link 2. So this is working as the input. This is working as the input. Next, if you proceed further, you can see here it is written the sun gear or the gear 1 is fixed, which means this one is fixed and its velocity has to be 0. Fine. And finally, one more value is needed, that is the rotational velocity of all the members we have to find when the input shaft rotates at 1200 rpm clockwise. So input shaft we have written here, this is the input shaft, and this is rotating at 1200 rpm clockwise. So the speed of R, or the speed of 2 we can write, because this is the link 2. So that is equal to y, and the speed is given as 1200 rpm, and because it is clockwise we'll just assume it is positive. So that becomes the value of y. This is equation number 1. Coming here, x plus y, this is the equation for n1, and we know the n1 value is 0, so 0 equals x plus y. So this is our second equation. Solving these two equations will give us both the values of x as well as y. So y value we already know it here. Substituting here x value, we will get minus 1200. So both x and y values we have found here, and by substituting these in the remaining gear functions, we can get their speeds as well. So if you want the speed of n3, we just have to substitute y and x here. So we'll have to substitute y, that is 1200 minus x. X is negative, so minus into minus it becomes plus 1200 into t1 by t3. So t1 here is 30 and t3 is 35. So solving this, we can get the value. So 1200 plus 1200 into 30 by 35. So that gives us 228.57. So 228.57. So 228.57. So this is the RPM. Because we are getting positive, this means it is rotating clockwise. So that's the solution for N3. So third gear is rotating like this. Coming to the fourth gear. The fourth gear, it's the equation is like this. So y value is 1200, and once again x value is negative, so minus into minus becomes plus 1200 into, this time we need t1 and t4. So t1 is 30 and t4 is 100. Once again calculating this, so you can use the same equation here. Instead of 35, we just have to put 100, and this is the value we are getting, 1560. So 1560. Once again, because it is positive, we can assume that it is rotating in clockwise direction. So you can see we found all the speeds. Fine, we found all the speeds using whatever data is given. So that's it for this particular question. Then this problem appeared in another of the paper, and you can see that the problem is exactly the same as the first problem we solved, and even the wordings are exactly the same. Only thing changing is the diagram. So here in this case, the diagram is found to be a bit more clear, and rest everything is the same.